Okay, Dean, the floor is yours. Go ahead and take it away.
Okay, let me see if first of all the cursor is working. It is. Great. Thank you, Ken. You're very kind. Ken is one of the pioneers in these webinars, and him and the PVRC, the Potomac Valley Radio Club, sort of exemplify for me the whole concept of giving something back to amateur radio. And Ken, you are to be congratulated for that. Today I'm going to talk about antennas for contesting. And going to use as the platform a comparison between a little gun and a superstation. Actually, a little gun is going to be kind of a medium gun in my talk here, but I'll discuss little pistols as well. So the picture on the front of of this presentation shows K6NV, Kurt Andrus, on one of the towers at N6RO, putting up a 4-element 40-meter Yagi, and that obviously is a big station. It's not a small station. All right. In past presentations, and as Ken has alluded to, I've given a number of them, and in various webinars. This is the 5th webinar I've done with PVRC, by the way. I've talked about antennas at multi superstations like N6RO, for example, W6YI, K3LR, and KC1XX. Some other ones also don't appear on this list, but I've used them as examples because it's much more interesting to talk about gigantic stations. But not everyone is a gigantic station or has a gigantic station. What about the little gun is the question. So today what I'll talk about is more modest antenna installations that can still give you a lot of what we call bang for the buck in contest or DXing. There's a number of tools that I use in preparing these presentations, and the ones that are primarily used are the VOA area program, which is part of the VOA CAP, Voice of America Computer Aided Predictions program. And this slide shows at the very bottom an HTTP, a tiny URL for a very complete discussion that I did about a year ago for details on making area maps. So if you want to reproduce some of the information yourself using VOA area, go to that URL and download the presentation, and it'll give you detailed steps on how to use the VOA area program. Anyway, so the first tool used is VOA area. The second tool that's going to be used in this presentation is HFTA, which is a program I wrote some years ago called High Frequency Terrain Assessment, and it allows you to assess what the effect of real-world terrain is using HFTA. Okay, now in the area coverage charts, this is something new. I've decided to go to get more resolution in the general signal strength range of contest level signals, which I define as being more than about S5 and somewhere at least in the S9 plus 10 region. This is shown in the, let me see if I can get the cursor going. This color here, this dark red color, is for signals that are S9 plus 10, which in VOA area is a minus 93 dBW. That is dB reference to a watt. And S9 signal is a dark brown signal, and that's minus 103 dBW, which in terms of those of you who are more familiar with dBm, that's dB relative to 1 milliwatt, is 73 dB. This is the classic Collins radio definition of what S9 should be. On the area coverage charts, the orange color is S8, S7 for yellow color, S6 for green color, S5 is the light blue color, and if it's less than S5, which by my definition of a contest level signal means that it's buried in the noise. In each one of these color gradations, each one represents 6 dB of change per S unit. And as I said here, S9 is 50 microvolts on 50 ohms, or minus 73 dBm, or minus 103 dBW, reference to a watt. Now the reason why I changed this compared to previous presentations is that I wanted to give more resolution for this S5 to S9 plus 10 contest level signals compared to my older presentations where I had used 12 dB or 2 S units per color gradation. Now, this is my rule of thumb, which I call very conveniently N6BV's rule of thumb. To run rate, that is, to be able to command a frequency and call CQ and have people come back to you, in a domestic contest, I define that the signal strength necessary is S9 at a minimum. Now, domestic contests would be something like in the U.S. and Canada, the November ARRL November sweepstakes contest. There are contests in Europe that for field day and various domestic contests. It encompasses a complete country, for example, the U.S., or in the case of Europe, a complete continent of Europe. And in Europe, I define it at least S8 is necessary, sometimes even more is necessary, especially on the lower bands, because frankly speaking, the Europeans don't always stop calling when you ask them to stop calling. So they require at least an S8 signal in order to take command and keep command of a pilot going. Now the reference for this this presentation is the station at N6RO, and that's the station I'll use as a standard of comparison. The antennas at N6RO are fairly impressive. They're on 80 meters. They're 2-element wire quads at 115 feet high. There's also a vertical 4-square on 80 meters. On 40 meters, there's two 4-element 40 meters with 42-foot booms stacked at 130 feet and 70 feet. There's also a vertical 4-square as well on 40 meters. On 20 meters, there's three stacked 5-element 20-meter beams at 130 feet, 90 feet, and 45 feet. On 15 meters, where I normally operate in the multi-multis at N6RO, there are three 6-element 15 meters, and they're stacked at 130 feet, 85 feet, and 50 feet. On 10 meters, there's three 5-element 10s stacked at 80, 60, and 40 feet. Now, the ground terrain at N6RO is essentially flat, so I use flat analysis. So those are the antennas at N6RO, and those antennas will be used in all of the comparisons. Now, the antennas in the background here are two of the 5-element 20-meter beams. This is the 130-foot high one. And this is the 90-foot high one at N6RO on 20 meters. Okay, so here's our little gun station, and I say little gun with something of a cheek in my the tongue in my cheek, because one of the things is that I'm assuming that this modest station has got reasonably decent antennas. It's got flat top dipoles for 80 and 40 meters, and that's at 55 feet high. And for 20, 15, and 10 meters, there's a 3-element tri-band Yagi at 55 feet. Now, I'm assuming in here that the that the transmitter power at the little gun station is 1,500 watts, which pretty much places it into a big little gun category. Now, for both the little gun and N6RO VOA area calculations, the antennas used in the receiving arrays in VOA area are the same as the little gun stations that are antennas that are listed above. That is, flat top dipoles at 55 feet for 80 and 40 meters, and 3-element tri-band Yagis at 55 feet for 20, 15, and 10. That's used on the receive side as well. Okay. This is an HFTA presentation of comparing on 80 meters a 2-element quad versus a flat top dipole at 55 feet, and the 2-element quad is at 115 feet. The blue color is for the flat profile terrain with the 2 elements at 115 feet. you can see that at an angle of, let's say, 10 degrees, the quad has a gain of about 4 dBi, and the dipole has a gain of about minus 6 dBi. So there's roughly a 10 dB difference between the dipole and the quad at an angle of 10 degrees. Now you may be wondering, in the HFTA presentation, gain is on the left axis, the takeoff elevation angle is on the x-axis, and these little bar graph spikes over here, for example, is saying that at a takeoff angle of 7 degrees, the percentage of time is 6% of the time when the 80-meter band is open, in this case from San Francisco, W6 San Francisco to all of the U.S. So it's saying that 6% of the time the angle will be at 7 degrees. If you look over here at 21 degrees, it occurs 4% of all the times during the entire 11-year sunspot cycle when the 80-meter band is open from somewhere in San Francisco to somewhere around the U.S. So this gives you a good idea on the angles to shoot for in coverage of all of the United States from San Francisco on 80 meters. Now, this figure of merit over here says that for the flat top 55-foot high dipole, the average gain over the whole 0 to 34 degree range of elevation angles, the average gain works out to be minus 1.3 dBi. It's an average figure of merit. And what it's saying is that between the two-element quad and the 55-foot high dipole, there's an 8.4 dB difference in figures of merit, and that comes out to just about 1.5 S units. So just glancing at this, it's saying that the 80-meter dipole at 55 feet is really behind the 8-ball. It's not going to work anywhere near as well as the quad on an average about 1.5 S units down from the quad, and that is true. And if you were in a pileup situation, one-on-one, N6RO calls and you're calling at the same time on 80 meters, if as little as a 1 or 2 dB difference can make a big difference on getting through that pileup to get to that station that you want to talk to. But how much difference is there in the area coverage for 1 or 2 S units less signal? That is where each S unit is 6 dB. So let's take a look at what I call the 80-meter little gun to the United States on 80 meters, that is 3.8 megahertz, during the month of November for a relatively high level of smooth sunspot number, a sunspot number of 100. Now on 80 meters that may make a big difference because it's not as affected by the point in the solar cycle as are the upper bands. This is for a 05 UTC. This is aiming the antenna from San Francisco right over here towards the east coast at an angle of a heading of 70 degrees for a 1.5 kilowatt transmitting station using a dipole at 55 feet. It says that all the way out to the east coast, the populous east coast, the signal level is S8. Into eastern Canada, the signal strength is S7, S9 into much of the Midwest, and S9 plus 10 to the western portion of the plains, the eastern portion of the plain states. So it's saying that this little gun is putting out a pretty good signal, S8 all the way out to the east coast. Let's see how it compares to N6RO with this 2-element wire quad at 115 feet. Now, instead of being S8 on the east coast, now the signal is S9. Let me go back and forth between those two. You can see them back and forth. N6RO, little gun. Let's compare them side by side. And you can see that there's not the thing that surprises me when I take a look at these graphs is that there's not a huge difference on 80 meters for domestic U.S. coverage. The 55-foot high dipole for the little gun is still pretty loud. Now, is he going to beat out N6RO in a pileup? No, there's no question about what's going to happen there. But calling, if you find a clear frequency and call CQ, you can do pretty well from San Francisco, certainly out to the Midwest, and even out to the East Coast with a relatively simple little gun station, provided that that little gun is running 1.5 kilowatts of transmitter power. Now, what takeoff angles does VOA area say that are needed in 80 meters to the USA? And I'll give you a hint right now, they're surprisingly low, especially to the Midwest. Now, VOA area can be programmed to show angles as well as signal strength. So here's angles. This is showing the N6RO quad at 115 feet. The angles necessary on the East Coast are in the pink range, that is from 15 to 20 degrees launch angles. In this portion of the Midwest, which almost reaches to Chicago, the blue color is between 10 and 15 degrees, and the yellow color is between 20 and 25 degrees. But what it's saying is that to cover both the East Coast and the Midwest, you've got to cover from 10 to 20 degrees, 10 to 20 degrees of elevation angle. Now let me ask you a quiz. How high must you be, how must your antenna be, for a peak elevation angle of 10 degrees on 80 meters? So assuming a horizontally polarized antenna. How high must you be to have the peak elevation angle of 10 degrees on 80 meters? How about 400 feet high? That always shocks the heck out of me when I think about it, but a 400-foot high 80-meter quad would have a peak angle of just about 10 degrees. Notice that the null in the response is just about 20 degrees. So it takes monumentally high antennas to achieve very low radiation angles on 80 meters. Let's see what happens into Europe on 80 meters from the little gun station. Again, a 55-foot high dipole, 1.5 kilowatts. Now the antenna is assumed to be aimed at 30 degrees as heading at 0.5 UTC on 80 meters, 3.8 megahertz in the month of November for a high level of solar activity. The little gun is putting out a signal that's less than S5 throughout Europe. In fact, on the western edge of Europe, you're just barely approaching an S3 level, an S5 level signal. So you're not from the west coast using a small gun, a little gun station with a 55-foot high dipole and 1,500 watts. You're unlikely to be able to run pileups into Europe. Let's see how N6RO does in comparison. Now you're running an S5 level into London and Paris and Brussels, but you're less than S5 into Berlin and Copenhagen and Oslo. So you're just beginning to reach the threshold of contest capability on using the N6RO station, whereas the little gun has relatively little chance of getting through in a contest situation where you've got loud signals spaced every 2 kilohertz or less on phone and spacing less than 250 hertz on CW. Now, there are times when the propagation is such that things will be a little bit better, or there may be thunderstorms over the East Coast during a contest so that they can't hear on 80 and 40 meters very well at all. And at that time, the W6 may be able to sneak in behind a big gun station on the East Coast who can't hear anything and work some Europeans. In fact, that happened to me one time during the ARRL CW contest in February. Back, this is about 3 or 4 years ago, when the East Coast was having a snowstorm, and they were having high precipitation static so that they couldn't hear anything on 80 meters. And I worked about 5 or 6 Europeans searching and pouncing on 80 meters from N6RO, but it took the two-element quad to do that, and it took some unusual weather conditions that disabled the other stations from being able to hear in order to achieve that. So 80 meters is rough from Europe to Europe from the West Coast, but all of us West Coast guys know that. Neither N6RO nor a little gun station is very strong on 80 meters to Europe. And as I said before, just to reach that threshold of just about being able to compete in a contest, N6RO requires pretty heroic antennas in order to get an S5 level signal into Europe. How about into Asia for the little gun? Into Tokyo at 10 UTC, again for a 55-foot high dipole and a 1.5 kilowatt transmitter. The little gun is laying down about an S7 signal into Tokyo, which you can work quite a few JAs on with an S7, especially since they are so well behaved in pileups. They'll actually stop calling when you ask for a JA0 and there's nobody on frequency that is a JA0. The silence is very eerie compared to what happens when you're trying to work a European pileup. N6RO to Asia, into Tokyo, about an S8 level signal. Into Saigon, it's less than S5, so it's, again, 80 meters is a tough band to lay down a huge signal into Asia, even using N6RO station. Comparing the two, there's about 1 S unit difference between the two in Tokyo, between the N6RO superstation and the 80 meter little gun station. Can the little gun have fun? You bet he can. He can have a lot of fun working Tokyo with an S7 level signal as opposed to S8 from N6RO. What's the 40 meter situation like? This is the little gun pointing into the USA. Again, 55-foot high dipole, 1.5 kilowatts. This is at 24 or 00 Zulu. On 40 meters for a high level of solar activity. Into Chicago, the little gun is putting an S8 level signal in with his dipole. Into the East Coast, the little gun is putting in an S7 level signal. Pretty decent signals, very strong throughout the western portion of the U.S. and strong in Texas and the Plains states. Compared to N6RO, this is N6RO, little gun, N6RO. N6RO with a pretty massive antenna installation of 2 4-element Yagis stacked at 130 and 70 feet is putting in an S9 level signal throughout most of the East Coast, into the Midwest and into the Plains states, putting out even stronger level signal. Comparing the two, you can see that there's a difference of about 12 dB or 2 S units on the East Coast. The question is, can the little gun still have fun? Can he still run pileups? Yes, he can, and he won't be able to beat N6RO in a pileup, but he will still be able to have plenty of good times on 40 meters into the domestic contest. 40 meters little gun into Europe. The westernmost edge of Ireland has got an S5 level signal for the little gun. The rest of Europe is less than S5. It's going to be tough to make to call CQ and make much of an effect on things into Europe from the West Coast using a 55-foot high dipole and a 1.5 kilowatts. but it can be done. Now this is the N6RO station, again with the two-element, with the two stacked Yagis, four-element Yagis, is putting in throughout much of Europe, including Eastern Europe, an S5 level signal, into the western part of Europe, putting on an S6 signal. In the tip of Iceland, it's an S7 signal. Can you run a pilot from N6RO into Europe? Unlikely, but you should be able to do pretty effective searching and pouncing, and that's what experience indicates at N6RO, that searching and pouncing can be very effective, picking up multipliers on 40 meters into Europe from the N6RO station. Side by side, you can see again the difference 2S units makes into Europe. It will admittedly be a struggle for the little gun on 40 meters into Europe. Into Asia, the little gun is putting an S8 level signal into Tokyo, Beijing an S6 level, Seoul an S7 level signal, into Saigon S5 level signal. So 40 meters can work a lot of Asian stations from the West Coast, but that's not a big surprise. This is N6RO, little gun, N6RO, putting them side by side. You can see that an S9 level signal throughout much of Asia is possible from the N6RO station. I've had, again, I point out that the receive antenna in these simulations, in these BOA area calculations, the receive antenna is a 40 meter dipole that's at 55 feet high. For those with two-element or bigger 40 meter beams in Tokyo, I've had many GAs tell me that the N6RO station is like 20 to 30 dB over 9 in Tokyo typically for the bigger receiving stations. Now let's look at 20 meters. The little gun to USA on 20 meters. This is at 00 Zulu, or 24 UTC in other words. For a 3-element Yagi at 55 feet, 1.5 kilowatts on 20 meters for a November. Oh, that's interesting. I changed the SSN level from 100 to 40 over here. This is just to illustrate that SSN, the smooth sunspot number, is not super highly critical on 20 meters. On 20 meters using the little gun station, there's S9 level signals all throughout the East Coast, throughout most of the Midwest. Part of the lower Midwest has S9 plus 10 level signals. So the little gun station is doing quite well into the USA on 20 meters. Now that's the 20 meter situation from N6RO. The stacked 5 over 5 over 5 make a difference. Little gun, N6RO, comparing side by side stacked N6RO's stacked 5-element 20s, doing pretty well. The little gun is doing pretty well. It's about S2 S units down in Boston, but an S9 plus 10 level signal in Boston from N6ROs would not be all that terribly different from an S9 plus, let's say 5 dB instead of 10 dB, or excuse me, S9 level signal compared to S9 plus 10. You can still work a lot of stations. You can still command a frequency and hold a frequency at S9 level. So the 3-element 20 meter beam at 55 feet for the little gun station is still very competitive. And again, it won't beat out N6RO in a pileup. It may take 3 or 4 calls compared to one or two calls from N6RO to get through, but still it will be able to run when you find a clear frequency. We'll be able to run a rate on 20 meters from a little gun station. Now, This is, again, 20 meters. This is examining this area in the Midwest, which I call a weak area. I mean, it's gone down to only S9 levels signal compared to S9 plus 10, the dark red surrounding it. What is going on here is that this is where the takeoff angles necessary are 1 to 3 degrees. This is where the propagation changes from a single F2 hop at very, very low elevation angles, changing to a 2 F2 hop at higher takeoff angles. And you can see the continuum here on, this is elevation angle here, this is signal strength, of course. What it's saying is that in order to get into the East Coast, the pink, the angles are between 5 and 10 degrees. In order to get into this weak portion, this weak area in the Midwest, you would need elevation angles between 3 to 5 degrees. Again, very low angles necessary to get into, let's say, Iowa. In order to get into Iowa from San Francisco. So the weak areas are where takeoff elevation angles are very low. This is a 20-meter little gun stationed to Europe. Now what's happening in Europe, again, the 55-foot high 3-element Yagi, tri-banner Yagi, and 1.5 kilowatts is laying down, the little gun is laying down an S6 level signal into most of Europe. Eastern parts of Eastern Europe are only S5, but your S7 into certain parts of Asiatic Russia, little portions of Asiatic Russia, and in Iceland you're laying down pretty good S7 level signal. These signals these signal levels are quite capable of allowing you to do good search and pounce multiplier searching in a contest from a little gun station. Things are a little bit better from an N6RO station's perspective, as you'd imagine. Here the peak level is about S8 into Scandinavia, Denmark, Sweden, Norway, and let's see, what else do we have here? Let's compare them side by side, the little gun on the left and the N6RO superstation on the right. There is admittedly about a 2S unit difference into Copenhagen, but this, at the levels that the little gun is laying down into Europe on 20 meters, there's still lots you can work. This is comparing, by the way, the N6RO stacks elevation response compared to a 3-element 20-meter beam at 55 feet. You can see that there's about a 9 dB difference in the average figure of merit, which amounts to 1.5 S units, almost 2 S units difference in favor of the N6RO stack. So now this shows the angles that are necessary to Europe from, again, this is from California to Europe. The angles are pretty low, for example, to get to India, between 4 to 6 degrees, 6 to 8 degrees throughout most of Western Europe. Eastern Europe goes as high as 8 to 10 degrees, and Asiatic Russia and far eastern Turkey goes 10 to 15 degrees. In general, the angles necessary to get into Western Europe are quite low. They're between 6 to 8 degrees. Now, let me ask you another question. How high must you be to peak at 2 degrees? How high must your antenna be to peak at 2 degrees on 20 meters? Guess what? We're back at our same 400 feet high that we talked about on 80 meters, which is 1/4 the frequency of 20 meters, and therefore roughly 1/4 the peak angle at that time was 10 degrees for 400 feet. This is 2 degrees, approximately 2 degrees for 400-foot high antenna over flat land, horizontally polarized antenna on 20 meters. So in order to achieve low angles into portions of Europe on 20 meters from California, you've got to have a really high antenna, or else an antenna that's located on very good sloping ground and a mountaintop, in other words. How's the little gun do to Asia? This is for, again, 2400 UTC or 00 UTC. 1.5 kilowatts, the 20-meter Yagi at 55 feet high. And it's saying that into Tokyo, at this point in time, the signal is only S5. It's interestingly enough stronger in Hong Kong and Saigon than it is in Tokyo at this time. This is just showing a snapshot of the band that's on 20 meters into Asia. N6RO is not super stronger, but where it illustrates the 2S unit difference in approximately 2S unit difference in average gain because of the stacking and also the height of the antennas. About 2S units into Saigon differential. Now 15 meters starts to get interesting in this analysis. Again, the 15-meter guy the little gun is assumed to have a 3-element 15-meter Yagi at 55 feet high and 1.5 kilowatts of power. This is again at 24 Zulu, 24 UTC, and on 21.2 megahertz in November during a smooth sunspot number of 100, a very high level of solar activity. This looks pretty familiar. There's a so-called weak area right in here where the angles are extremely low. Take a look at this. Keep your eye on this section of the U.S., the East Coast, where this is for the little gun. Let's compare N6RO. You see that N6RO is actually weaker in the East Coast than the little gun is. That's using a stack, a 15-meter stack of 6 over 6 over 6 at 130, 85, and 50 feet. Pretty magnificent antenna system, but the little gun with this 3-element Yagi at 55 feet is actually beating out N6RO by about an S unit in this portion of the geography. There they are side by side. What is going on here? It turns out that the top N6RO antenna is too high above ground to give the a good elevation response for 2 F2 hops to the East Coast. This is the angles that are needed. The angles that are needed in this area right over here are the pink ones. They go from 10 to 15 degrees. Let's see. Here's the response characteristic using HFDA of the stack 6 over, well, actually I use 5 element stacks over here. 5 elements, 130, 85, and 50 feet high. It's got a peak angle of about 7 degrees. Covers the low angles nicely, but what happens over here if the angle were to be like 16 degrees, which occurs about 4% of the time, the response of the stack is down here maybe minus 3 or 4 dBi, whereas the response of the 3-element tribander is about 12 dBi. So there's about 15 or 16 dB of difference in favor of the little gun at about angles greater than about 12 degrees. Now, this is another way of looking at it, where instead of looking at antenna elevation angle or takeoff elevation angle or signal strength, now we look at the transmitter gain. And the transmitter gain is somewhere between, in the green, it's between 3 or less than 3 dBi, which is what the HFTA analysis indicates that the gain at the angle that's necessary is about 3 dBi right over here. So it says that the incoming angle is somewhere about 14 degrees. Now, what can be done with this? I mean, this is a travesty. N6RO is getting beaten out by a tribander at 55 feet. What can N6RO do to take care of this situation? And what N6RO can do and has the capability of doing is switching out the top antenna so that the stack, this green line right here, oops, what happened? Just a second, I got lost. Okay, so this green curve right over here is for a stack of 85 feet and 50 feet, and compare it to the blue line, which is the stack at 130, 85, and 50 feet. The peak gain of the two stack, the stack at 85 and 50, is down about a dB compared to the big stack, the tall stack. But now at 14 degrees, it's got a gain on the order of 16 dBi as opposed to a gain of somewhere around 12 dBi. At 14 degrees, the difference is even larger, at about 15 dBi for the two stack and approximately 5 dBi for the stack of 3. So by switching out the top antenna, you gain coverage because you cover more of the elevation pattern necessary. And so this is what happens when you compare side by side now. The weakness is gone on the East Coast. Now N6RO is S9 plus 10 dB, just like the 3-element Yagi at the Little Gun Station is S9 plus 10 dB plus 10. No, excuse me, it's S9, and the N6RO station is S9 as well. So it's possible to compensate for having an antenna that's too high, especially on the upper bands, 15 and certainly on 10 meters. 15 meters little gun into Europe. Portions of Western Europe where it's S6 signal level occurs. In the eastern portion of Europe, well, in the eastern portion of Europe, it's less than S5. In London and Paris, it's about S5. This is for the little gun again by itself into Europe. N6RO puts a stronger level of signals into Europe as might be expected with the stack. This is back to the 3 stack at 130, 85, and 50 feet. There's a significant difference on consisting of 2S units in Europe in favor of N6RO, but the little gun will still be able to work the stronger Europeans, get those multipliers. 15 meters, again, that's no surprise. It should be no surprise that the angles necessary into Europe, the angles necessary, whoa, just a second. The angles necessary to Europe are between 2 to 4 degrees, 4 to 6 degrees in the blue. In general, the angles to Europe are low from the West Coast. This is comparing the stack on a 3 stack of 130, 85, and 50 compared to the 3-element 15 at 55 feet to the little gun station. Little gun to Asia, N6RO to Asia, about 1 S unit down from N6RO with a 3-element tribander at 55 feet. Again, that's pretty competitive. It takes a tremendous amount of aluminum to have a really overwhelming signal compared to even a little gun station at 55 feet. 10 meters, this is to the USA for the little gun, for N6RO, little gun, N6RO. Comparing them side by side, there's a significant difference on 10 meters to western Midwest, but the little gun is still competitive. After all, a S9 level signal or S9 plus 10 level signal throughout the Midwest is not a bad signal at all for the little gun. To Asia, little gun, N6RO to Asia. There's a significant difference to the Far East, but an S8 level signal to Taipei for a little gun is going to be sufficient to get a lot of multipliers in Eastern Asia and work a lot of JAs. In other words, 10 and 15 meters, it doesn't take as much to be competitive because now your antenna height as a function of wavelength above ground is higher effectively at 55 feet than it is on 40 meters, for example, or 80 meters, where 55 feet is not that much of a portion of the wavelength. Okay, what about terrain? This is comparing a 3-element tri-bander at 55 feet on flat ground, that's the little gun, compared to W6NL's 3,400-foot mountaintop using the same 3-element 20-meter beam at 55 feet. And W6NL is very close to the superstation status anyway. You can see that having a mountaintop makes a big difference on the response covering all of the Midwest at S9 plus 10, no less than S9. But the little gun is still pretty darn competitive, except in certain small areas where the signal strength is not as strong as it is in the mountaintop station. Now, I've been using a 55-foot high tower with, what about a low dipole for a tiny gun instead of a little gun? This is comparing to a dipole at 35 feet, a tiny gun, a little gun with a 3-element 20-meter beam at 55 feet. There's almost one unit, S unit of difference, but the little, well, I'll call him a little pistol here, the guy with a dipole at 35 feet on 20 meters, can still put down an S9 level signal into the East Coast and still be surprisingly competitive. Should be able to still have lots of fun. Now that's assuming still that he's running 1.5 kilowatts of power. Now, more realistically, comparing a tri-bander at 55 feet and 1.5 kilowatts to a dipole at 35 feet and now 100 watts instead of 1,500 watts. Now we're going to call this guy a little pop gun as opposed to a little gun. The little pop gun is a bit more challenged, but he's still capable of putting an S7 level signal onto the East Coast, which is again enough to do effective searching and pouncing in a contest. Lately, on one of the reflectors, there's been a very long and torturous discussion about IMD and splatter. And this is an example of IMD products. The third order products are down on roughly 40 dB compared to PEP, peak envelope power. This is on a Orion, one of the original Orion, on 20 meters, which is pretty decent. Pretty good, about 40 dB down in adjacent voice channels. And the IMD products, the 7th and the 9th and the 11th are all down on the order of 65 dB. That's a reasonably good transceiver. Now, what kind of signal would this level of IMD put out across the U.S.? Here's 55-foot high tri-bander, 1500 watts. This is N6RO, big stack on 20 meters. This is what the IMD 40 dB down will produce. In other words, it will produce a level of about S5 on the East Coast. And an S5 level of splatter with superstation antennas, is that good enough? I'll leave it to your own conscience, but I suggest that that's not very bad, a level of splatter, and that's on the adjacent channel to the main channel, producing a S5 level signal on the East Coast. I suspect that the next to a big station like N6RO, 2 kilohertz away, there's going to be another big station who's 20 or 10 or 20 dB over 9, and the S5 level splatter is probably not going to cause much interference at all. Okay, getting close to the end of this, Ken. Everything works, and I say everything works sort of. N6BT, Tom Schiller, wrote in the July 2000 QST an article about everything works, and pointed out that the range of HF antenna gain is not really all that huge. It goes from about minus 20 dBi if you were to feed a dipole, a light bulb, your antenna gain would be somewhere on the order of minus 20 dBi to a stacked set of Yagis that produce close to plus 20 dBi. Now this is a 40 dB range, but it's not a 100 dB range. This 40 dB range covers antennas such as a radiating light bulb all the way to a stack of monoband Yagis. So the range of an HF antenna gain is really not that huge in the real world. What I've done today is try to present comparisons between a big gun multi contest station such as N6RO and a more modest little gun station with a tribander and a dipole on 40 and 80. Usually the big gun was stronger by about 2 S units due to the antennas alone, because in each case I assumed 1500 watts of transmitter power. And certainly while it's true a little gun can be effective, he's not going to be able to steal the N6RO run frequency, but he can have a whole lot of fun working contests or DX. Further listening or reading, this is, as I said before, the 5th webinar I've given with the PVRC people. Thanks to the PVRC people. There are also a number of webinars up on the Northern California Contest Club. That's my contest club, the NCCC, or Northern California Contest Club. Click on webinars. Furthermore, on the pvrc.org website, there's recorded webinars. Click on that for additional reading. There's a number of different presenters on the PVRC and also the NCCC websites. Now, the tiny URL that I referenced further was for information on area coverage charts. That's how to use VOA area, and the presentation is entitled "Seeing the Big Propagation Picture," and it was a talk that I gave at Visalia back in 2011. So that's about it, Ken.
Okay, very good. Why don't you keep your slides up in case you need to go back to them. So, time for questions and answers. There is a questions box. You can just type your question in there and hit return, and we'll go ahead and pick that up. Dean, actually, let me go ahead and ask the first question here, because we do have quite a few people in Europe joining us. If they were looking at the plot maps that you did, would it be accurate if they just reversed the transmitting and receiving stations? In other words, if you're in Europe and you've got a small gun station, would that project the coverage back towards like California and so on? Could they just reverse the two and get a fairly accurate representation of coverage from Europe, if that makes sense?
Yeah, that makes sense, and that's indeed what would happen. They could reverse the sense of it and say that, let me get into Europe here. A little gun station into Europe, well, perhaps this is not too exciting. Let me find one for like 20 meters.
Because I know with the vol cap and area you can swap the transmit and receive stations.
Yeah, exactly.
Yep.
Exactly. So if you're in let's say Berlin right here, and you're receiving, or N6R, a little gun in California is receiving an S6 level signal, the little gun in California will be receiving an S6 level signal from you in Berlin.
Or if someone in Europe wants to build an N6RO style station, then the other maps would apply and be good to go.
Oh yeah, absolutely.
Okay.
It all scales. It all scales, Ken.
Good. All right, let's get to some of these questions. We've got a couple of them here. First one's from Elmer Smart. What website do you use for the smooth sunspot numbers?
The NWA site, Northwest Research site. If you go up to the ARRL website and do product notes, search for product notes, click on antenna book, and download the file for HFTA. Well, let's see now, HFTA, and also download the file for I can't remember the URL. Anyone can go ahead and email me a question where I can do a little bit more research on it, Ken. Just n6bv@arrl.net. And I'll send you back the URLs of things that are escaping my memory right now.
Okay. All right. Next question comes from Europe. Stuart, GW0 Echo Tango Fox. What was the orientation for the 80 and 40 meter dipoles at San Francisco?
Okay, the orientation of each antenna, both at the receiving end and the transmitting end, was assumed to be right on the nose. In other words, the Yagis are pointing in the at the correct heading in order to get to GM0, and the GM0 had an antenna that is aimed properly at W6.
Okay. Someone wanted to see your last slide, so you go ahead and put that up, and I'll ask the next question once you get that up there.
These will all be on. You're archiving them, aren't you, Ken?
We can. The presentation's recorded, and if you want to make the slides available, we could put those up as well, or link to them.
Yeah. Okay. Here's the last slide.
Okay. Dr. Scott, K0MD, Dean, is always nice talk. What do you advise for the stations who cannot put up Yagis, verticals like the Step IR or a series of monoband wire dipoles?
Well, it depends. Hi, Scott. It depends on where you're located. Are you located on the seashore, or on a de-expedition to an island, or are you located in the wilds of Minnesota? I guess I can't get a direct answer from him quickly unless Scott, you've got a microphone connected up, and we could go kind of go live here. If you're in the wilds of of Minnesota, where you've got some flat ground that's relatively high conductivity, a vertical will usually perform better at lower angles than a horizontal, simply because it's difficult to get a horizontal antenna up all that high, especially on 40 and 80 meters. So to really answer your question, I'd have to go into a pretty detailed analysis of what frequencies you're doing and what kind of terrain you're dealing with and what kind of soil conductivity you're dealing with. I was not just being facetious by saying that if you have a vertical out on the beach in Guatemala, you will have a stronger signal than a 3-element Yagi at 60 feet with just a simple vertical, simply because of the way verticals operate over salt water.
Okay, a couple of questions regarding stacks, and wondering if you have, this has come from a couple of people actually, one from Dave, Kilo November 7 Sugar. What type of Yagi stacks do you advise, 2/2, 3/3, and then also optimal stacking distances for tri-banders? That last one on the tri-banders came from Scott, K0MD.
Oh, yes. Well, he has stacked tri-banders. I know he does. Magnificent 40-foot boom, I think it is, tri-banders. Let's put it this way. Starting with tri-banders, tri-banders are, the spacing on tri-banders is going to be a function pretty much of the guy wire spacing on your tower. I know that back in New England, when I lived back in New Hampshire, I had a 120-foot Roan 45 tower with 3 TH7 high-gain tri-banders stacked at 90, 60, and 30 feet. And that combination worked out extremely well. The spacing was just a little bit short on 20 meters, and it was just a little bit long on 10 meters, but it was fantastic on 15 meters. But it worked on 10, 20, and 10, 15, and 20. It worked on all bands very, very well. But when you're talking about stacking antennas, I mean, obviously, if you can stack 6-element Yagis, you're going to do better than stacking 3-element or 2 elements. It all depends on how much effort and money you want to put into the system, and how much your wife will allow you to put up. That's another very important factor.
Okay, let's take a question from Brazil. Luke PY8 Alpha Zulu Tango says, hi, we know 1 to 5 S units makes a big difference, but on the low bands it seems to be an even bigger difference. Why?
Wow, it's hard to say. By low bands,
if sometimes they tend to be maybe a little noisier or something that factor into it.
That's certainly a factor. It's certainly on the low bands in the subtropics. It's difficult to hear because of static crashes. I know that one time I went on a de-expedition with the Team Vertical group down to Venice, down to Jamaica, down to 6Y, and one of the things was that our location was such that we had an excellent view towards Europe and towards the U.S. and Japan. And right behind us in the direction of South America, there was a huge mountain. And we could hear Europeans down all the way down to the pin, the S-meter pin, down to S0. We could hear and work Europeans, whereas in other locations that were exposed directly to the lightning storms in Venezuela behind us, the mountain blocked them, but if we had been in flat territory without that mountain behind us, we wouldn't have been able to hear much of the 80-meter signals, simply because of the lightning storms and the thunder and crashes that came from Venezuela. Why do I say Venezuela? Because the next year we went to 4M7 X-ray, and we could hear the noise right in our backyard with lightning strokes coming down, all in the antenna field. So we had a really tough time hearing under those circumstances. So that may be part of it, as Ken has indicated. That's the ability or the inability to hear makes a big difference on the low bands.
Okay. Oh, yeah, Luke also says he'd love to see some graphics to Papa Whiskey 7 Tango. So pass that along for you.
Well, okay, that's an advertisement for the antenna book, because the HFTA and all propagation information is included with the antenna book, the ARRL antenna book.
Okay, there you go. All right, this is one of the beauties of this webinar, the reach we have out to India and Deepak, VU2 Charlie Delta Papa, for an apartment dweller who can only put up one antenna and not a Yagi. He's wondering if you have any suggestions between a dipole, trap vertical, and this would be at a height of 120 feet on a apartment roof.
Well, I would say that I would personally go with a horizontal dipole of some sort, because you're up high enough to get good low elevation angles, and unlike a vertical, it's less susceptible to electrical noise coming from the apartment or coming from nearby neighbors, and it's usually very difficult to hear in an apartment when you're using a vertical. I think that's about it. Yeah,
okay, no, it's fine. I was typing a response to someone else here. take a couple more questions. This is from Eric, W4DXX. How does a Foursquare compare to a dipole on 80 or 40 meters? That would be to Europe, to Asia, some of the areas you covered.
Well, it depends on the ground situation, the conductivity and dielectric constant of the ground. As I said, any kind of vertically polarized antenna over salt water is absolute magic. I mean, the angles, the elevation, takeoff elevation angles can easily be 1 or 2 degrees out of an array like that over salt water. Over rocky rocks in New England, or it becomes more of a challenge, but because the lack of ground conductivity means that the vertical array is at a disadvantage because it doesn't have good ground to work with. However, that having been said, experience of guys up in the W1 northeast region, the New England region, who have Foursquares on 80 meters always do better than horizontal antennas, simply because it's very, very difficult to put up a horizontal antenna that's got takeoff angles that are 10 degrees or lower. As I pointed out in one of the first slides in my presentation here tonight, a 400-foot high dipole on 80 meters produces a peak angle of 10 degrees. Well, in order to achieve one at 2 degrees, which a lot of the very far DX, distant DX is coming in on the lower bands and the upper band as well, you've got to be very, very high, or else on a mountaintop, in order to challenge the Foursquare on 80 meters. Certainly 160 meters is even more challenging in terms of height necessary to achieve a low elevation angle from a horizontally polarized antenna.
Okay, a couple questions here and then we'll wrap it up. This one is from Tony K4 Queen Echo. For sake of comparison, was the 3-element antenna for Little Gun a trap tri-bander or a 3-element monobander?
I used a model of a monobander, but you know, plus or minus 1 dB maybe it'll reflect, or minus 1 dB it'll reflect the capabilities of a tri-bander. A tri-bander on a long boom like a TH7 can do remarkably good things.
Okay, Jeff, G4 Fox Kilo Alpha, for a small station with only small wire antennas, say fixed sloping dipoles, is it worth having a couple at different angles? Will it make much difference?
Sloping dipoles don't give you a lot of gain. They'll give you a little bit of directivity in receiving. So to the extent that you've got noise that you're trying to eliminate, slopers will help you on receiving some, but they don't give you anything really in terms of actual transmitter gain, just a little bit of directivity. I would, frankly, if you're trying to emphasize certain positions, put up wire 2-element Yagi, and you'll gain some forward gain, and you'll gain some rejection of signals off the back, so that'll help you receive. And then when you want to work another part of the world, you put up another dipole with a reflector on it. Did we go dead, Ken?
But, you know, it would help if I would unmute my microphone. I'm talking to myself. It's not the first time either. Last question, and then we'll wrap this up. Comes from Vince, K4 Japan. Charlie, what do you think of stacking log periodics?
Well, stacking anything is better than not stacking, but log periodics to me, unless you really and truly need their wide bandwidth coverage, are a compromise antenna. That simple Yagi, of course, I'm contest oriented, so I think in terms of 10, 15, and 20 meters, tri-band Yagis. But if you also want 12 and 17 and possibly even 30 meter coverage, then a log periodic may be more appropriate for you than individual Yagis.
Okay,
stacking log periodics works just as well as stacking Yagis does. It fills in the gaps. In fact, I talked about. I guess the first webinar that I gave with PVRC, which was August 5th, 2009, contest antennas, DX or domestic, what's your pleasure? I discussed a lot about about the advantages of stacks and why people stack. It's a bit more subtle than just a brute force.
Okay, very good. Well, we need to wrap this up. I'm sorry, there are a few more questions there. I think Dean said he was available via email, n6bv@arrl.net, so you can shoot him a question. Anything else, Dean, before I wrap this up?
No, I think that about does it. My voice is gone, so it must be the end of the webinar.
Okay, very good. Well, one thing I just wanted to mention, we had almost, I think, 300 people register for this. We didn't. Typically, we don't get that many that actually show up, but it's just a real testament to the reach. I mean, you know, big crowd from North America, South America, a lot of Europeans, and also, as you heard, some friends in India, Japan, and around the world. So it's pretty neat to be able to do this and to have people like Dean take the time to share their expertise with us. So we appreciate that, Dean. We do have one other webinar scheduled coming up, and those of you who were here will get that. There'll be a follow-up about a day from now, and it'll have details on the upcoming webinar. It's by Carl Litzelschwab, K9LA, looking at the current status of cycle 24, and he's got a couple other interesting topics I think you'll like. So that'll give the date, times, and registration information as well. So we must be done. My wife's calling me on the cell phone. Probably means the generator at home is just about out of gas. I had mentioned at the beginning some of the weather problems we had. I had to come up here to Washington, D.C. to the Voice of America club station because they've got power, internet, and they've got air conditioning. So I'm going to get ready to leave and go back home, and I will not have any of that stuff probably. So, okay. Thanks, everyone, for coming. Have a great weekend. We'll see you on the bands. See you on the next webinar. Thanks again, Dean. Everyone take care. 73, so long. Bye-bye.